we have a solution of HCl that has a pH of 0.6. So that means that we have H and Cl minus and H2O. And we know that the H2O also has H plus and OH minus equilibrium going on. Into this, we're going to add 1.0 grams of NaOH. And we're told that this is 250 milliliters of HCl. So we can find out the concentration of the H plus ions using the pH, because we know that the concentration of the H3O plus ions in this solution is going to be 10 to the negative 0.6. Once we know that, if we look at our equation that's going on, HCl plus NaOH makes NaCl plus H2O, and we don't worry about the Cl's in the NAs because we know that the ionic version of this equation, the total ion equation, looks like this. And so with excluding the spectator ions, we know that that's what's going to happen when we add the NaOH. So if we can find out the number of moles of H plus ions that are in there and the number of moles of OH minus ions that we add, then we can figure out which is in excess, which is the limiting reactant and which is in excess. So let's do that. Let's say 10 raised to the, so that's the 10 to the x button on my calculator, negative 0.6. And we have that the concentration of H plus ions is 0.25 molar. Now technically 2 decimals in the pH, 2 sig figs in the concentration. So we have a 0.25 molar and we have 250 milliliters, which is 0.25 liters. And so the number of moles, 0.25 times 0.25, should be 0.0625 moles of H plus. Now of the hydroxides, we're putting 1 gram of NaOH. So if we times that by 1 mole of NaOH for every 39.99 grams, or 40, you can round this, of NaOH, we find that there's going to be 0.025 moles of NaOH. Now, we know that that's a 1-to-1 when it breaks apart, so we know that we have 0.025 moles of OH minus. So which of these is smaller? Since it's a 1-to-1 in our reaction, we're going to use up all our OHs. Every OH is going to match up with an H and make a water. So when we're done, this will be the limiting. This will be in excess. How much in excess? Well, we had 0.0625. It's a 1-to-1, so we're going to use 0.025. So we're going to have 0.0375 moles of H plus left in our beaker of H3O plus. So the question asks, calculate the pOH. So I'm just going to find the pH of this. pH is equal to negative log 0.0375. And pOH plus pH has to always equal 14. So we can find the pOH by doing 14 minus the pH. So we'll do the negative log of 0.0375. And we get a pH of 1.4. And we need to keep the 2 decimals, so 1.43. So the pH is going to be 12. So the pOH is going to be 14 minus 1.43, which will be 12.57. Okay. So remember, we had a pH of 0.6, we went to a pH of 1.43. As the pH goes up, that means less H plus ions in the solution. That makes sense because we started with 0.0625. And, oop, I have a mistake here, actually. Look, I did 0.0375, negative log of 0.0375, but that's the moles. We have to put molarity in here. So let's fix that really quick. Sorry about that. Easier to just fix it than go start a new video. So we have 0.0375 moles left in the beaker after the reaction. That was what was excess. We started with 0.0625 moles of H+. We used up 0.025 because the OH is the limiting reactant, and we ended up with 0.0375 moles in 0.25 liters. So we need to get our concentration. And that gives us 0.15 molar. Okay, which has dropped from our original 0.25 molar. We should have less because we've used up some of it. So we do negative log of 0.15. Sorry about that, mistake. So negative log of 0.15. And we get the pH has gone to 0.83. It's gone up, but not as much. 0.82. pOH plus pH has to equal 14, so 14 minus 0.82, so we get 13.18 is the pOH, and that was what they looked for.